Okay, keep going.
And then don't you distribute the 1/2 to the 27 plus 5?
Well, I would add them up first because they add up nicely, and then taking half of an even number is better than taking half of two odd numbers.
Okay. So is it 18 plus 16?
Yes. Which is
34.
34. Okay. All right. So assuming you get that right, yeah, they would move you on to a more difficult question. And just to be clear, what I'm sending you these are not formatted well. The Alex is formatted a lot better. I'm just going out and trying to find something that would be similar. So this one is slightly more difficult than the last because they require you to substitute in the numbers and perform the steps.
Okay.
Okay. Like I said, it's not formatted well. Minus 3x plus 4c minus r divided by g. If you've got some paper handy, I would recommend substituting in your variables. Do that in parentheses. You do get paper. It's not like you don't have stuff to write with. Substitute in for r, substitute in for g, and see what you come up with.
Is the answer 16?
I'm not quite up to you. I was going to give you a little time there. So let's see here. We got 6 plus 12, and then you got to kind of deal with these negatives. 3 negatives make a negative, so minus 2. So yes, it is 16. Okay. All right. So from here, like if you were to get these two problems right, and I believe you would, you would probably move on to something that's more difficult. And I should also say this about the test: there's just as likely to be fraction answers as whole numbers, and we can maybe talk about that if I can get to where I can see that. So here's another problem for you to look at. You were asking me earlier about distributing. Yes, you want to do that and then combine like terms.
Okay. 2x plus 3y minus 14.
Like that. Okay, so minus 2x minus 6 plus 4x plus 4y minus 8 plus negative y. So it looked like 2x for sure, I like that. And then 3y minus 14, good. Okay, so I'm looking for some more difficult stuff here because I know that it gets there. So I'm looking at, and I know this, I'm gonna drop this in the chat because I think this link is fairly useful. That link there, it's got a lot of information at the top that you don't need. And then it gets to this part where it says general review for the PPL assessment, which is the placement. And they give you some links here to some things. I started clicking on them. I mean, they're not all that they're not all that self-explanatory, you know, but there are some resources there. I was looking for some more practice problems. So here, let me see if I could find one that might be good for us to look at. All right. Yeah, so here's a problem kind of based on what we just did. So this would say to solve for y as an example here.
Mhm.
Okay. And there is only one variable. So the goal would be to get the variable on, you know, move them all to one side. And then to, you know, get everything else in the other. So how do you think we should start here? What would you recommend?
Um,
I'd focus on the fractions here.
yeah. Would you multiply by 8 to get the 3y minus 5 by itself?
Yes, multiply everything by 8. And that also affects these other fractions over here on the left. Can you tell me what the new equation is after you multiply by 8?
Is it 8y over 2?
Yes, but what does that reduce to? And that's kind of the key thing is being
Oh, okay. So that just reduces to 4y.
okay, keep going, doing great.
And then the 1/8 that reduces to -1.
That's correct. And then how about on the other side there?
And then that leaves you with 3y minus 5.
Okay, good. So how do you solve this for y?
I would I would subtract 3y
Okay,
from both sides. So that leaves you with y minus 1 equals -5. And then would you add the 1?
yes.
So then that's y equals -4.
Yeah. Now they actually always give you one where it's not a great answer, which is what I was kind of looking for on this one, meaning like it ends up being like y equals like 23 over 16. Okay.
Mhm.
And there's always a practice problem like that. So let me see if I can give you one like that. Yeah. So this would be a problem like that. So let's go 3x over 5 minus 4 equals -6 plus x over 3. Okay, so just like the last problem, you do have to figure out what to multiply everything by. And it's not just, you know, the larger number on the bottom, it's It's what's called the least common multiple between 3 and 5. Excuse me.
The least common multiple would be 15.
Yes. Okay, so you have to multiply everything by 15, both sides. Could you tell me the next line fully simplified with the fractions, no fractions basically on the next line, please?
Would it be 9x minus 4 equals -6 plus 5x?
You have to multiply everything. You multiplied the first one, but not the second one.
Oh, okay. So 9x minus 45.
15 times 4, 60. 15 times -5 is -90.
Okay.
Yeah, so just double check that, make sure you're in agreement with that.
And then does that leave you with 4x equals 30?
-30, because you're adding 60,
Yeah.
subtracting 5x. Yeah. That's a 4x equals -30. And this is one of those where you would have to present your answer as a fraction, like plan on using fractions unless you see a calculator icon.
Okay. -7 1/2.
It's got to be a fraction. So like a numerator and denominator only, top and bottom.
Oh, okay. That would be -30/4.
So this would be marked wrong because it has to be reduced. Like while you're correct, it's not what they're looking for. It's a computer grading it. Computer can't acknowledge that it's correct. It just says, nope, it's not the same as what I want.
-15/2.
Yes. Yes. And I hope you hear that it's not Matthew that's being picky. It's me trying to tell you this is what the test expects.
Okay.
Okay. Do you want us to do one more like this or move on to something else?
One more like this, please.
Okay. Let's go 3x/4 minus 2 equals 6x. Let's go. So let me go 5x/12 plus 1. Again, you're going to solve for x.
Okay. X equals 3/4.
So I got a slightly different number on my side here. What did you multiply everything by?
I multiplied everything by 12.
12. Okay, that's good. And let's just work this out. 12 times 3 is 36. 36 divided by 4 is 9. Did you have 9x here?
Yes.
Okay, and then you multiply the second thing by 12, so that's minus 24. Then it becomes 12 times 5x divided by 12. The 12's cancel, so it's 5x plus 12. How does this look compared to what you've done?
I didn't multiply the -2 and the 1.
Okay. Yeah, and that is a common mistake. You're not alone doing that. But the thing is, it's not multiple choice, not like the SAT, ACT, where you can kind of hint at the answers. It's just a free response.
Yeah.
So can you solve it from here?
Yeah. X equals 9.
X does equal 9. Good. Okay. Now you almost certainly will get a problem like this where they give you they tell you to do some factoring. Okay, but it's not, unfortunately, it's not the kind of factoring that you're thinking of. It's like 72 over 9, w to the 5th, x to the 7th over r to the 8th, b to the 9th, minus 16 over 27, w squared, x to the 9th, r to the 10th.
Mm-hmm.
And it probably just looks really bad, but and I've probably chosen one that's way too difficult. So we can come back to this, but this is the kind of problem they'll kind of throw at you, and it looks really, really challenging. But do you want us to try this, or do you want us to kind of lead into this problem with a couple of less complicated ones?
Can we start with something a little less complicated,
Sure,
please?
sure. So let's say I put something like this in front of you: 50x squared y cubed minus 75 xy to the 4th. Okay. When you're factoring, or when you're looking at something like this, you're looking for the greatest common factor. And you first start with the numbers. You're like, okay, between 50 and 50, what's the biggest number that goes into both?
Um,
Any guesses?
is it 150?
You're looking for a number that goes into both. That you're giving me that's the least common multiple is what you were just giving me, is 150. Yes, that is
Oh,
150.
common
It's going the
factor.
other way now.
25.
25, yes. And then when you look at x squared and x to the power of 1, you're looking for the smaller exponent.
Okay.
What would that be?
The smallest exponent
Of
is
x. Yeah, between x squared and x to the 1.
x to the 1.
Yeah, so you kind of got to do it in groups here. Yes, okay, I'm gonna look at all the x's, and then I'm gonna look at all the y's. Right? Y cubed, y to the 4th. What's the DCF of y cubed versus y to the 4th?
Y cubed.
Y cubed, good. Okay, but that's not all. It's not going to ask for just the GCF. It's going to say, okay, use this GCF and divide each of these by the GCF, and then rewrite the GCF here and what goes in parentheses here. Basically,
Um,
what happens when you divide each of those by the GCF?
okay. Is it,
So you want to just do it? Okay, go ahead.
is it just 2x?
For the first one, it is 2x, so not too bad. How about for the second one?
For the second one, it is 3y.
3y, good. Okay, now let's try another one here. Let's try 14x squared y cubed over w to the fifth minus 18x squared w to the fourth. So it's kind of a rinse and repeat here. You have to look at the numbers, 14 and 18,
Mhm.
and just be like, okay, what's the biggest number that goes into both?
Is it 2?
Just 2, yeah. Now you go just letter by letter between x squared and x squared.
Um, and then it's x squared.
Yes. Okay, and then y cubed and nothing.
Y cubed.
It's the smaller one. If there's really a y to the 0 here, which is the smaller exponent, 3 or 0?
A 0.
0. And there's a reason it's not there. It's because it doesn't contribute. So there's nothing for the y's. How about the w on the bottom?
And then the w is w to the 4th.
Good. Okay. Now this is where kind of when I show it where you have to divide each of these by it kind of doesn't work great because you're dividing by a fraction,
Uh-huh.
but it is still correct. It's just that it may not make sense. So the other way is to figure out, well, what goes here such that when you multiply by 2x squared over w to the fourth, you get back to the original. Or you have to divide each of these by this, which maybe looks worse than it actually is. It's kind of the same thing. You just cancel, look for the cancellation, like 14 divided by 2 is 7, x squared divided by x squared is 1, w to the fifth divided by w to the fourth is w, but it's now on the bottom.
Okay.
So maybe saying it wasn't as helpful as doing it, but 14 divided by 2 is 7. Y cubed remains and a w on the bottom. And then if you can visualize multiplying in by this, 2x squared times 7y cubed, w fourth times w, could get you back to this previous line.
Okay. Is it just 9?
For which one? On the one on the right?
Yeah.
Yes. Yes, exactly. Okay, you now know enough to attempt this one here, although I'm going to change a couple of the numbers. I kind of went to the extreme on that. So let me do this. Let me change this to let's just do 9 and 30. Okay, so go ahead and try this one on your own, please.
Is it,
Give me the GCF first. That's the, to make sure we're,
I got 3 for the GCF.
anything else?
Um, for the GCF, no.
The GCF includes the variables.
Oh, I got 3W squared.
Okay.
X to the 7th.
Okay.
Over R to the 8th.
Okay, good. Now what goes inside parentheses, if you've got it?
On the left, I got 3W over
Anything
E.
else? It's 2, you got to get to 5.
Oh, W to the 3rd.
Okay, over.
B9.
Good. Keep going.
Minus, it's 10W.
So you already have a W squared though. So that
Oh,
W cancels with that W.
so is it just 10X squared
And what about on the bottom?
over R squared?
Yes. Okay, that was possibly more difficult than what you might see on the test there. So next, let's do some inequalities. Is that okay?
Yeah.
All right. They don't make them easy. They don't give you just, this would be the most vanilla inequality you might see on there.
Okay.
When you're solving an inequality like this, make sure you remember to, if you multiply and divide by a negative, that you flip the inequality.
Okay. X is greater than -10.
Okay, so adding 5, that sounds right, minus 2x. And then x greater than -10. You would also be asked to graph this. And so it'll give you a number line. And then you have to remember to put an open circle on -10. And then you have to fill in everything to the right of it like that.
Okay.
Okay. But like I said, that's probably not going to be the type that you will get. They often make them a lot more difficult. It's kind of like you get the hardest one of every type of problem you might have seen in previous course. So here you go. Here's another inequality. You have to be able to distribute and move things around.
X is greater than or equal to 2/5.
Something like this.
Yeah.
Okay. So now let me just check here in case you want to look at the work later. Minus 3x minus 6. I got to ask, did you distribute the -4 to the 1 and the -3 to the 2?
Yes.
Oh, good, good. Okay, now you have a choice, right? You can move the -3x left or the -8x right. Which did you do?
I moved the -3x to the left.
Okay, it's not a right or wrong. I just want to follow your work here. -5x -4 less than or equal to -6. Add 4, add 4. -5x less than or equal to -2. And then you correctly switched the inequality here. So x greater than or equal to 2/5. Good. Okay, and you might think, all right, doing great. So let me kind of lead you to the problem you might see. So here's one you might see. And this is the solution to the problem. And we'll get back to how to actually do it. But you might see something like this where x is less than -2 or x is greater than 3/2, something like that. Okay, so these are called compound inequalities. Does that at all sound familiar to you?
Yeah.
Okay. So it might be something like this, and they actually switch up the variables. 5 minus 3r less than or equal to 8, or 2 times r minus 1 less than or equal to 7. All right, so would you attempt to solve both of these and tell me what you come up with?
And then do you leave the fraction as like a improper fraction, or do you?
Yeah, you don't generally convert them to mixed numbers anymore.
Okay. So for the one on the left, I got r is greater than -1.
On the one on the left here.
Yeah.
Yes, r is greater than or equal to -1. Good.
And then for the one on the right, I got r is less than or equal to 9/2.
It's like this.
Yeah.
Okay, so here we go. Let's look at this on a number line. The first one is r is greater than or equal to -1. The next one is less than or equal to 9/2. What does the or mean to you? If or I can provide an example. Like when someone says or, what does that typically mean?
There's two options.
But they both could be true, right? They could be like, I want to go to I don't know, I'm gonna go to San Diego or I don't know, Los Angeles, but you could go to both, right?
Mhm.
So here, when it says or, it's the overlap. Okay.
Okay.
So what would the overlap of I'm sorry, not the overlap. It would be anywhere anywhere one or the other is true. So like the net sum of these is everything.
Oh.
Now, what if it was an and? What would an and look like if it said they had to both be true? They switch colors for this.
If they're
I'm gonna
both
read.
true, what does and
Yeah,
mean?
and means they're both true. Like, uh,
Yeah.
let's see here, -1 to the right, 9/2 to the left. But let's say it's an and situation. They have to both be true. Where are these both true?
In between -1 and 9/2.
Right. It would be bracket -1, 9/2 bracket.
Okay.
All right, so let me just see if I can find one more of these. Here we go. Yeah, so here's another one for you to look at. You do have to solve them both. Unfortunately, there's no way to work around that. Just go ahead and solve them. And let me know if you have any questions, of course.
Okay. Is it 9 is wait.
Which one did you solve first? The one on the left or the one on the right?
The one on the left.
Okay, so I'll help here. You're going to subtract 12K minus 9K less than or equal to add 3 minus 9, divide by minus 9. So K is greater than or equal to 1.
Okay.
The one on the right here, just 'cause we're running out of time here, add 17K to both sides, add 7 to both sides. 4K less than or equal to -8, divide by 4. K is less than or equal to -2. Now, because it's an or, it can be either true. So here's -2, here's +1, all the numbers to the left of -2, all the numbers to the right of +1. All right, and you typically get something that complicated on the placement test. Where at? Okay, I don't know if you still have that link that I sent you in the chat, but that'd be a good place to start if you got more time, which maybe you don't because you're busy.